Alrighty, y'all. So what we're going to be talking about today is special right triangles. More specifically, on the front page, we're going to be talking about 45, 45, 90 triangles. And on the back page, we're going to be talking about 30, 60, 90. So when we're looking at 45, 45, 90 triangles, we are going to be talking about triangles that have two legs that are going to be labeled with an x value and your hypotenuse, which is going to be labeled with an x radical 2. All right, so x radical 2. All right, and your x radical 2 is always going to be opposite of your 90-degree angle or the box. Okay, and then your legs are going to always be opposite of your 45-degree angles. So if we look at example 1, what we're going to do is we are going to want to start out labeling our variables. All right, so we're going to want to label our x radical 2. And so we should know our x's are across from our 45-degree angles, so we should know that x radical 2. And so all I'm going to do is I'm going to look where I have two things written. So I should be able to see that I have two things written right here where I'm highlighting in blue. And so that's like a name, all right? So I am calling those two things the same name, so they are equal. So x is equal to 10, all right? So now that we know that x is equal to 10, it should be pretty easy to figure out the rest of our sides because we're just going to plug in for x. So we're looking at side AC first. So side AC is going to be this side right here. And so we're just going to plug in for our x here. So we get that x is going to be 10 radical 2, and that will be my final answer, 10 radical 2. And then BC is just represented by an x. Well, I said x is equal to 10, so my answer is just 10. All right, looking at example 2. All right, again, x radical 2. So across from the hypotenuse is my x radical 2. And then my two legs are x. All right. Again, I'm going to highlight where I have the same thing labeled. There's the double. So x is going to equal 3 radical 2. And so I'm going to plug in. So I'm looking at CT first. So CT is this side over here. So I'm going to plug in 3 radical 2, radical 2. All right, so what happens here is this is really just 3 radical 2 squared. And when I squared a square root or a radical, it just cancels out. So all I'm left with is 3 times 2, which is going to be 6. All right. And then my AT is going to be the same as my other side. So it's just going to be 3 radical 2. All right. And then I go over here to example 3. I'm going to get x radical 2. All right, and then there's a nice little cool trick here. Easiest way to look at this is I see that the things I have doubled is this right here, right? And there's a reason I wrote them stacked like that. Because all I'm going to do is when I have something like this stacked perfectly, I can just mark out what's in common. So that tells me right there that x is going to equal 3. All right, so I now know that x is going to equal 3. So both of those sides are just going to be 3 and 3. All right, perfect. Now moving on to question 4. I'm going to get x radical 2. This one's going to require a little bit of work. So x radical 2 is going to equal 18. I'm going to divide by a radical 2 on both sides. Cancels out here. So I get x equals 18 over radical 2. And you should remember from simplifying radical lesson that you cannot have a radical 2 on the bottom. So you have to multiply by a radical 2 on top and on bottom. So we will be left with 18 radical 2 over 2. So this just becomes 9 radical 2. So x equals 9 radical 2. And so now JA is going to be 9 radical 2, and then JG will also be 9 radical 2 because both of those are just x. All right, question 5. Find the exact perimeter and the exact area of the following triangles. All right, these are very, very important words here. All right, there's a reason they're all in bold. If we're asking for exact, we're not asking for estimations, so we're not going to be rounding, okay? We want the exact decimal. All right, so 14 radical 2, and we're given a 45-degree angle, and then we're given a 90-degree angle here. And so you should be able to infer that this is 45 degrees because we know that there's 180 degrees total in a triangle. So we know that this is x, and this is x radical 2. So we should be able to say that this is 14. This is 14 because x is going to equal 14. So for perimeter, you're going to get 14 plus 14 plus 14 radical 2 because perimeter is just adding all the sides. And then for area, you are going to get half base times height, which is going to equal half 14 times 14. And so when you end up working these out, it's going to be half times 196, which equals 93 inches squared. And then 14 plus 14 is 28. So 28 plus 14 radical 2 would be your answer there. Inches. Okay. All right, on to the back side. Alrighty, now we're going to talk about 30, 60, 90. And for 30, 60, 90, the most important thing to remember is that your 2x is going to be across from your 90-degree angle, and across from your 60-degree angle is going to be your x radical 3. All right, across from your 30 is going to be just your plain x. All right, so for 30, 60, 90, it has 3 different things that you're working with, okay? So let's go ahead and move to example 1. So how I always start these questions is I always ask, where does my 2x go? So my 2x is going to go across from my 90-degree angle, so it is going to go right here. Where does my x radical 3 go? It goes across from my 60, so it goes right here. And then where does my x go? It goes right here. And then we're going to follow the same process as we did for the 45, 45, 90 triangles. So I'm going to highlight what's the same, and I just set it equal to each other, all right? So x equals 10, and I'm going to plug in, all right? So for a JG, x is 10, so I'm really doing 2 times 10. So JG is going to equal 20, right? And then for AG, I'm going to plug in, I'm going to get 10 radical 3. Hopping over to example 2 here, I'm going to ask the same questions. Or I'm going to, ask the same questions. Where does my 2x go? My 2x is going to go here with this 30. Where does my x radical 3 go? It goes across from the 60. And where does my x go? It goes across from the 30. And so then, again, highlight things where I have repeating, and I'm going to set it equal to each other. So 2x equals 30. Divide by 2 to solve that. So I get x equals 15. So my OU side is going to be 15 because it's just x. And then I get 15 radical 3 there. All right. Moving over here. Again, where does my 2x go? Goes across from the right angle. My x radical 3 goes across from the 60. And then my x goes across from the 30. And again, highlighting. And I can follow the same rule as the x radical 2 and mark out the things that are in common. And so I will get that x equals 20 here. So UR is going to be 20. And then I'm going to solve right here. And I'll get that TR is going to be 40. All right, y'all. Hopping down to question 4. 2x is going to be with this x radical, or 2 radical 3. My x radical 3 is going to be with across from the 60. And then my x is just going to be right there. And so then now I have to set this equal to each other. So 2x equals 2 radical 3. But there is a shortcut here, all right? And this is what I want you to see, all right? That same shortcut works, all right? So the same shortcut works. I can mark out... Oh, no, ignore me. I can mark out the thing that is in common. So the 2 is in common, right? So in reality, x just equals radical 3. And I'm going to show you if I divide by 2, because that's what I'll do, right? It's going to cancel on both sides. So x equals radical 3, right? So it does work out. If you're able to see the shortcut, use the shortcut. So in reality, ON is going to be the side that is just radical 3. And then MN is going to be radical 3 times radical 3, which is radical 3 squared, which cancels out the radicals. And so I'm just left with a 3. All right, looking at example 5. Again, we see these words exact. All right, those are our keywords. All right, and so I see my 30-degree angle, my 90-degree angle. Well, then I should be able to make an educated guess that that is going to be a 60. So across from the 90-degree angle is going to be my 2x. Across from the 60 is going to be my x radical 3. And across from the 30 is going to be my x. So again, I'm going to solve for x. So 2x equals 12. Divide by 2. I'll get that x equals 6. So this side is going to be 6. This side is going to be 6 radical 3. And again, I'm going to set up my perimeter first. So 6 plus 6 rad 3 plus 12. And since I want an exact number, I'm going to get 18 plus 6 rad 3 inches. And that will be my perimeter. And for area, I'm going to do base times height, or half base times height, sorry. And so I'm going to do half 6 times 6 radical 3. So in other words, I'm going to do 6 times 6, which is 36. Radical 3 divided by 2. So in reality, that is just going to be half of 36, which is going to be 18. Radical 3 centimeters squared. And I told y'all that was inches. On the perimeter, it's centimeters in this question. All right, y'all. If y'all have any further questions, make sure to ask your geometry teacher. Have a good one.